In this video, we're going to see the topics analog digital signals, noiseless and noisy channels, bandwidth, throughput, and latency. So let us start with analog signal. So analog signal means the signal is continuous. It changes smoothly over the time without any breaks. So human voice is an example of analog signal. When we speak, the sound waves are continuous, right? Next is digital signal. Digital signal means the signal is not continuous. We can say the discrete one. It changes in steps and usually only uses the values 0 and 1. So traffic light signal is the example of digital signal where it changes step by step like red, yellow, green. It does not change smoothly. Next is noiseless channel. So noiseless channel means a communication channel in which the data is transmitted without any noise or disturbance. So the received data is exactly the same as the sent data. The best example we can say USB cable. You transfer a photo from your phone to your laptop via USB. The photo arrives exactly the same. No pixel is lost here. And next example we can say LAN cable, Ethernet. You copy a file from one PC to the another in the same room through a LAN cable. The file arrives perfectly, so there is no corruption. So a noiseless channel is any medium where sent data is equal to received data. No bits are lost or flipped. No interference exists. But in real world, no channel is perfectly noiseless. Some disturbance always exists. That is where noisy channel comes in. Noisy channel means a communication channel where noise or disturbance is present during the transmission, which may cause errors in data. The best example we can say a mobile phone call in crowded area where you hear voice disturbance due to network interference. Next is bandwidth, throughput, and latency. So what does mean by bandwidth? Bandwidth is the total capacity of a communication channel. Okay, so bandwidth can be measured in two ways, that is hertz and bits per second. So when a bandwidth is set in hertz, it is the difference between the highest and lowest frequency a channel can carry. So bandwidth equal to Fmax minus Fmin. So it shows the signal capacity used in analog communication. Okay, for example, if a channel is 1000 Hz to 5000 Hz, then the bandwidth could be the 4000 Hz. Bandwidth in bits per second. So this is actually about data capacity. It is the maximum number of bits that can be transmitted per second. So it is used in the digital communication. For example, network is equal to 100 Mbps. It means it can send 100 million bits per second. So how they are connected means more frequency bandwidth means more data capacity. Okay, so this you should need to remember every time. Increasing frequency range increases data transmission rate. Next is throughput. Throughput is the actual amount of data successfully transmitted over a network in a given time. It is the real performance of the network, not the ideal one. So it shows how much data is actually delivered. It depends on real conditions like traffic, errors, and device speed. For example, a link has bandwidth of 10 Mbps. Due to congestion and delays, only 2 Mbps data is actually delivered. So here the bandwidth, the total capacity is 10 Mbps and throughput is only 2 Mbps. Next is latency. Latency is the total time taken for a message to travel from the sender to the receiver. Okay, it is how long it does it take for the data to reach the destination from the moment the first bit is sent to the last bit is received. So latency is equal to propagation time plus transmission time plus queuing time plus processing delay. So what is meant by the propagation time? Time taken for a signal to travel through the medium. This propagation time can be measured using distance by speed. So it depends on the distance and the speed of the signal. Next is transmission time. Transmission time means time needed to push all bits into the network. Transmission time is equal to message size divided by bandwidth. So it depends on the file size and the bandwidth. Next is queuing time. Queuing time is the time spent waiting in routers and switchers. So it increases when the network is busy and traffic is high. Processing delay means the time taken by the devices to process the packet. For example, error checking, routing decision, etc. And we can also say the latency is the total time taken from the sender to the receiver, and also we can say it is a total delay experienced by the data packet from the source to the destination. That's all. Thank you.